higher derivatives.
Okay, so today we'll be looking at under differentiation of Wassky electric math concept, looking at higher derivatives, Okay, now what are higher derivatives? Anytime if y is a function of x, if y is a function of x, that is to say y, if y is equal to any function f of x, either is a polynomial function of x, either is a quadratic function of x, any of them. Then, if you differentiate this, you will get dy on the x. If you differentiate the function, this y equal to f of x, you get dy on the x, and it's the same as what? F prime of what? Of x. F prime of x, and this is known as the first derivative. The first derivative. Now, if this is the first derivative, when you differentiate the first derivative, that is to say, you define the dy of the x, of the y function, the derivative of the second one, which is dy dx. So you find the dy of the x of the first derivative, you get the second derivative, which is what? The square y of what? The x squared, which is what? The square y of what? The x squared. And that will give you, is the same as f prime of x, and it's known as what? The second derivative. Now, if you find the dy dx of the second derivative, the square y of the x squared, you'll be getting the third derivative, which is what? The cube y over what? The x cube, or the f prime of x. And this is known as what? The third derivative. So now what happens is that as we move on differentiating with respect to each derivative, you'll be getting what? Higher derivatives. Let's take two examples. And let's see what we can do. Okay. Now the question says that if we have y is equal to x exponent 4 minus x exponent 3 plus 4x minus 1, we should find dy of the x, the square y of the x squared, and the cube y of the x cube. Okay, so now you have been given this function, we are asked to find these derivatives of it. So now y, our solution, you have our function y in terms of x cube plus 4x minus 1. So therefore our dy of the x is simple. We find the derivative each term individual. So this will give you 4x cube. This will give you 3x, 3 minus 1 squared. This will give you 1 times 4, which is 4 times x, 1 minus 1 minus, so here is 1 already, 1 minus 1, which is what? X exponent 0, so it's 1, and this derivative will be at 0, so you don't bring it. So this will be the first derivative, and the person says you should find the second derivative, which is the y squared over what? The x squared. But take note that this is the same as the derivative with respect to x of the first what? Derivative. I getting it. So you are differentiating this first derivative. So now differentiate this, you get what? 12x squared minus 6x, the constant will give you 0. Okay. Now the third one says you find the third derivative. The cube y of what? The x cube, and this is the same as d on the x of the square y over what? The x squared, the second derivative. So differentiating the second derivative will give you the third derivative, which is equal to what? You get 24x, and this will give what? Minus what? 6. Okay, so this is the idea of what? Higher derivative. You can go as one as differentiating the fourth derivative and the fifth derivative. That is what? Higher derivatives. Try your hand on this question. If y is equal to 3x exponent 4 plus 2x plus 2x minus 2, find I, the y on the x, I, the square y on the x squared, and I, the cube y on the x cube. So try a hand on this question. Yeah, you should try a hand on this question. Thank you.